So let's see, in this problem, sorry, I have to move my microphone for a second there. Okay, so in this problem, we're talking about dependent probabilities. We've spent a lot of time talking about independent versus dependent. So let's see what we need to figure out to do dependent probability. So a dependent probability is one, right, where we find that they are not, that the first event impacts the second event or impacts the probability of the second event. So a lot of times those problems are written out just as they are right here. I want you to look at this. Look what it says. It says, without putting the first one back in the jar. So it'll say that, you select the problem, you select the marble out, and then you do not replace it. And therefore, the number inside of the set becomes smaller. So let's just see what this would look like. Okay, we have a jar. Here we're going to draw my little jar, right? And it's just so beautiful, my drawing. So I know you're happy to see this drawing like this. Now inside you have 5 red marbles. So we have 1, 2, 3, 4, and 5. We have 4 green marbles, so there's 1, 2, 3, and 4. And we have 2 blue marbles, so we have 1 and 2. So now we choose another marble, and then we choose a marble, then we choose another marble, but we don't put the first one back in. So what is the probability that the first marble is going to be blue? Well, we have, let's see how many total marbles in the jar. So the blue probability, the probability of blue is going to be equal to, I have 2 blue, so the n of blue is 2. That's the number of elements that are blue. And then the n of the total, and at this point my total, I'll do this in black, but I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that is, I can go back here and say out of 11. 2 out of 11. That's my probability of blue. But then I have a second event. And it says, what is the probability that the second will be red? So the probability that the second is going to be red is going to be equal to, well, I've got 1, 2, 3, 4, 5. And then guess what? I only have 10 left because I took a blue out, right? So this guy would be gone. Actually, I shouldn't use red to cover him up. Black covers him up because he's gone. He's in the middle of nowhere. Okay? So now that means I only have 5 out of 10. So now when we find multiple probabilities to find the total probability, we're going to multiply. So we would say 2 over 11 times, now 5 over 10, that's 1/2. So I'm just going to make this a little bit simpler and go 1 over 2. And then I see when we're multiplying and there's a common factor top and bottom in our fractions, we can cancel those guys out. So my answer is going to be 1 over 11. So where did that come from? Well, I figured out 2 out of 11. I think you followed how I did that. And then 5 out of the remaining 10, right, which I reduced to 1 out of 2, and then we just multiply across. So that's how that one is done. Let's oops, I didn't mean to do that. Sorry. Let's put in our answer, 1 out of 11. Okay, and we can see that's how it's done. Let's go to the next problem. All right. Same thing, only now look at how this is so crazy now. Instead of a jar, it's a goblet. So you get to see my drawing of a goblet. Okay, not very good, but you can imagine this one. There it is. Okay, so I have 2 red. So pretty simple. We just put 2 red in there, 2 green in there, and 5 blue in there. So here we go. Choose a marble, then another marble, and here's the key, without putting the first one back. Now, if I put the first one back, then these would be independent. The 2 events, the first event being choosing the first marble, and the second event being choosing the second marble, the two events would be independent, because if I put them back, the probabilities are going to remain exactly the same. Okay, so that's that we're going to figure. Sorry about that. Get my thing there. So when it's the only when the odds or the probabilities change, it's because I didn't put the first one back in, and now I have a new number in my space. The n over, right? The n in my event A goes over n in S, and then what I have when I go for event B is I actually have n in S minus 1, because I'm not putting my marble back. Do you see how that works? So that's basically how that works. All right, number of A. Here we go. We've got A being, what is the probability? The first is red. Okay, well, I can do that. My red are 1, 2, so that is 2 over 1, 2, 3, 4, 5, 6, 7, 8, 9. 2 over 9 times, then the probability the second is also red. Aha, ooh, this one's kind of good, because now there's only one left that's red, because I took one out, and it's over 8. And I can reduce this, because this is 2 times 4, so the 2's would cancel, and then we just end up with 1 over 36. Man, that starts to get pretty tough. The idea that we're going to have both the red marbles come out, the probabilities get pretty tough. 1 over 36. That's how those are done. You go ahead and work through these dependent probabilities.